Okay, so look at the biopsy data, which has morphological data on tumors. Okay, so I guess we've got.
I think we're predicting benign versus malignant.
Yep. And we've got 9 predictors or features. Let's just look at it. Yeah, so we're going to use V1 to V9 to predict class. And so the way we do it is from the LDA, but we perform a MANOVA, but then we don't really use the MANOVA here. So I've kind of, I don't know which of this code I've put in, because I did this like a week ago, and which of this code is in your
None of it.
your file. Oh, okay. So you probably want to remove the ID variable. That's not going to help us in the models. Here I'm just using indexing and saying -1, so get rid of the ID variable. A better way to do this, because you don't always want to rely on numbers of variables, because if you say I decided to change something, the numbers of variables can change. You can actually just specify which names of biopsy is equal to ID. So which is I'm finding it more and more useful just in terms of like finding which row is the row I want to operate on, or which column is the column I want to operate on. And then names biopsy equals ID is just going to return a true or false vector, basically saying which names of biopsy are equal to ID. And then if you put that inside which, it just returns you the number that's true. So if more than one was true, it would return more than one number, for example. So I'll make it a bit larger. Okay. So yeah, remove the ID variable. So now you've just got all the V's and benign and malignant. Okay, so I'm going to create a training set. So using sample, this function you've seen before, I'm going to sample the numbers from 1 to however many rows this data set has. It's got 699. So I'm going to sample from 1 to 699 randomly. And if you do this without setting a seed, you'll get a different training set than me. So you'll get slightly different results, but that's fine.
Sorry, there he said that there's some predictor of these 16 missing values.
Well, I didn't, and it seemed to work fine. Where does he say this? Oh, 16 values are missing on V6. Huh. Yeah, that might be a good idea. Let's just do that. So, like, who remembers how to do that?
To do what, sorry?
Remove the cases with missing values in the data set. What's that? Yeah, that's one way. Or there's another function. NA omit. That's what I was looking for. There's definitely many ways to do it. So let's see what happens. Biopsy is currently 699 observations. Yeah, it takes it down to 683. Okay. Yeah, everything seemed to work fine without doing that. Possible that the LDA that I did left out those cases just on its own. I'm not sure, because some functions will do that. But yeah. So yeah, now I'm going to take a sample. So the second function in sample specifies like the sample size to take out. And so here I'm just saying the floor of n-row biopsy. That actually divided by 2 should be inside there. Oh, no, it shouldn't. Yeah. No, that was right. So floor is just going to round down. So this function gives me 341. because it's taking the whole sample size, dividing it by 2, and then rounding it down. And then replace equals false.
And what does the for mean? It just means that's how many you're going to use for your training.
Yeah. That's the sample size. Use 80% of the data for training. Yeah, oh, it does too. Okay. So not divided by 2. Let's instead do times 0.8. So that'll give us a training set size of 546. Okay. And then replace equals false. We're not doing bootstrapping, so we want a sample without replacement. Okay. So they're my train IDs. It's not my training set yet, but it's going to specify the training set. So the LDA is pretty simple. Just we need this formula class tilde dot, and then to specify the data, which is just biopsy, and then specify the training set inside the index.
I didn't understand what in his original example we had that prior. That looked like it said if you have some knowledge about the probability.
Yeah. So the prior is related to, I guess there's some kind of something slightly Bayesian going on under the hood in this function. Sort of, I think you can think about it this way. So say I'm trying to detect which people in a population have a disease, and say that disease is very rare. So I know that only 1% of people in the population have that disease. So then if I have a new case and I'm trying to classify that case, I have a very low prior probability on whether that case is going to have that disease or not. Something else, I might know that about 50%, just have sort of a prior belief that about 50% of cases can be classified as having that thing or not. So it's just basically related to do you want to specify some prior probability? And so leaving it out, what leaving it out does, and I was looking in the function to sort of understand this, what leaving it out does is that it doesn't really use a prior, it just uses the observed probability in the data as the prior, which seems like a smart thing to do in most cases to me. Because if I have a sample, that's probably going to be my best guess about the likelihood of classifying cases in that sample. So
And does it use the observed from just your training?
I think so, yeah. So based on the training set and the overall probability in the training set, it's just going to use that observed probability as the prior. Okay. So we do that, and we see that it only gives us back one LD. So I guess only one is significant, whatever that means in this case. And then we do this MANOVA. But as you see, like it's when we did the MANOVA up here in the earlier part of the tutorial, we did it z.man, and then we got this s.z.man thing. But then the predictions came from z, which wasn't the MANOVA. Z was the LDA. So we're just doing this MANOVA again, but it's not actually going to be related to the predictions that we make. So probably not that important. So I'll kind of skip over that. So now we want to make predictions for the test set. Okay, so this code will do that. So we can predict from our LDA object, Z, and then we give it the new data set, and it's very important to put this minus sign before the train. So it's just saying use the cases not in the training set. And then $class is just, I guess, going to specify to give us those predictions on benign or malignant. So if we run that, we can look at what our preds are, and these are just all the predicted values for benign and malignant. And it's interesting that it's given us so many of them. I guess what this is, it's giving me 606, 608. I would have thought the test set would be smaller than that. That's yeah. Train ID. Error in terms of formula. Dot in formula and no data argument.
Mine says object.
Yours says what?
Object V1 knockdown.
Oh, that could be related to. This is working fine earlier. Okay, so I would go back to get the data again, and head of data again. So you should see ID, then V1, all the way to class. Get rid of ID again, and then maybe just check that it worked. So just go head biopsy again. And then emit the NAs. Head biopsy again. Okay, we're still looking good. Let me see if there's anything going wrong here. So that should be fine. So our train ID should be 546 numbers. A comma?
Not you.
Oh.
It's us. I think we're missing a comma, so we're running it.
Oh,
At least that's what I did. That's what I got wrong. You put a comma after the negative train.
okay.
Then it fixed it for me.
Okay.
Yeah.
I don't know if that's what it is.
So yeah, okay. So I don't know why, but now it's working for me.
It's weird because the Z thing works for me, and then I can see my Z. It's just that when
When you're calling
You
the
have
data,
spreads.
calling the data and the predict, did you do a negative train comma in your browser?
Yeah.
And it works.
no, it doesn't work.
Oh, it's not. Yeah,
Maybe if you run.
Oh, maybe I just need another. I think I'm missing a parent. This is. Didn't keep it. It's for example, I thank you for
No,
your
no.
support.
I think,
Put my parent in the wrong space.
but parentheses is plural. What's
You're right,
what's the
actually.
singular?
Parentheses.
Parenth-
Parentheses.
It is IS instead of, yeah.
Parenthesis.
Like
Parentheses.
thesis.
Yeah.
Yeah.
Missing a parenthesis.
Yes. Yeah.
Yeah.
It's always,
That was a mistake. So you should use train ID.
Or whenever you name it.
Okay. I'm just going to delete the man over stuff because it's preventing people seeing code here. So all this should work. Like when in doubt, it's always good to start again. So like I'd go back to biopsy, start again, get rid of ID again, emit the NAs again, make the train IDs again, do the LDA again, and predict for the test set again. I think provided all the commas are in the right place and the train ID and the parentheses are in the right place. Is anybody still getting errors? Okay. So now my preds, yeah, now I'm getting the right amount of preds. This looks like 20% of the data now. Okay. So now what we want to do is work out false positive rates, true positive rates, false negative rates, true negative rates. And so to do that, I want to get the true values for the test set. So that's just going to basically call this variable using indexing, so minus, that should be train ID, and then specifying the class variable. So if we look at what truth is, these are just all the true values. And what I've done is maybe a bit convoluted. So basically I just made an empty vector called res, which is all NAs, but it's the length of my predictions. And then just one by one, I've used indexing to, basically change res to true negative when the prediction is benign and the truth is benign. Change res to false negative when the prediction is benign and the truth is malignant, and so forth. So now I'm just going to end up with this vector res, which is going to, for every single case, be either Tn, Fn, Tp, or Fp. And it's not that much coding because most of this can be copied and pasted onto the next line. But there's probably a more elegant way of doing this.
Which with the same, so the same thing that you have in yes, which it didn't. Is there a way to do it with which? Like if I could do which for one, but I can't do multiple criteria. Or
Well, you should, because all which needs is a true/false statement. And when you add the and, you can make two things into a single true/false statement. So which should work fine here, actually. But which is almost superfluous, because what the indexing does is it's going to act on the cases that are true here anyway. So I think that which is probably not necessary. Yeah, there would be a lot of ways of doing this. I could see maybe, I don't know, this just seemed to make intuitive sense to me. So on 177, we can just make a table of res. I haven't made it yet. To show us the overall proportions. So 4 false negatives, 2 false positives, 80 true negatives, and 51 true positives. And then, I did this very overly complex way of calculating sort of sensitivity, specificity, and overall accuracy, but you don't need to do that. You could just use the numbers from the table. So how would I calculate sensitivity, for example? So sensitivity is, out of all the people who do have this thing, so who are malignant, how many did I identify? Or what proportion? Well, yeah, but it's true positives over the sum of true positives and false positives.
Well then, true positive
No,
divided by.
I think it's the reverse of that. I think it's true positives divided by true positives and false negatives.
No, so sensitivity is proportion. No. So if somebody has it and we said that they didn't have it, yeah, that's a false negative. You're right. Yeah. So what would my sensitivity be here?
Or just res $sign TP for experiment.
Yeah. I think, yeah. So this is kind of, the way I did it down here was just, yeah, way too complicated. But yeah, 51 over 55, I buy that.
But that works because
true.
our numbers are different from yours because of the setting C.
Yeah.
So your code would work always, whereas our numbers would be off.
Yeah, I guess that's true, yeah. I mean, you need to go by your own table of results, yeah. So, but it's basically true positives plus false negatives is going to be in the denominator. And then specificity is how many people that I call positive really do have this, really are malignant. So that would be, again, true positives over true positives plus false positives, exactly. So that would be 0.96. And then I don't know what you actually call the overall accuracy. So like you can just calculate the proportion correct over all the predictions, which is what we did above. But yeah, that's it. That's pretty easy. 1058. So we got there. Is anybody else getting an error or want to go back to something?
For the overall correct, I mean, that's just going to be the true values of all the testing, right?
Mhm. So this is extremely accurate. I mean, I guess that's good, right?
It's predicting malignant tumors.
Malignant tumors, yeah.
It's like probably a good one to be.
Yeah. You don't want to be a false positive. I guess you really, really don't want to be
We don't
a
want a false negative.
false negative would be the worst, right?
False negative would be the bad one.
Yeah, yeah. And they happen, right? Like, it's not. We got 4 false negatives here. Those people are screwed. So I guess you should get multiple tests.
Well, I guess it
Get a second opinion.
It's something intrinsic to you that makes the test fail, in which case multiple tests are not going to help.
Hmm.
You'd hope it would be something intrinsic to you and just be your
Sampling error.
an error.
Yeah.
It's actually certain
I guess that would depend on how the test works.
Multiple simultaneous tests combined.
That would make sense to run that
The
way.
chance of being negative on all of them.
Hmm.
Yeah.
Makes sense. I don't remember which cases that's for though.
Yeah. I mean, psychologists don't really have tests like this. Like, do we? I mean, is there any way to determine false positives or false negatives of a psychological diagnosis? I'm not sure about that because doesn't the diagnosis sort of determine
Yeah, it's
the
not like
disease status? Yeah.
I've seen them done where they have like tests versus like then evaluated by a psychiatrist being the true version.
Yeah, yeah,
And so like you can do this for a given diagnostic tool.
yeah.
But there's
Hmm.
yeah, there's usually like a gold standard for that to like a person.
Yeah, and the tests are validated against
Right.
the expert judgment. So it's like, I always found that interesting that like
Yeah.
we're like, oh, we don't rely on expert judgment anymore. We have like objective tests, and those tests were validated against the expert judgment because there was nothing else. Yeah, it's interesting. All right. Well, on that note, thanks. Thanks, guys. It's been an enjoyable semester, and I wish you all the best on the final. And yeah,
Thanks for leading us through this journey.
Thank you for all of your
it's
help.
been, yeah. You're welcome. How do I stop this thing? I think, yeah, okay.